Now, if I have a point here in space, let's project this point onto the xy plane. Now, let me join this point in the xy plane to the origin. Good. Now, if I know the angle theta, the angle the line makes with the x-axis, that is my projected line, and let me call this projected line here r, and the distance from the point to the origin, let me call it r, and I know the height still remains z, then I can get to the point, right? So we say that cylindrical coordinate is characterized by r, theta, and z. R, theta, and z. Right? R, theta, and z. Now the relationship between cylindrical and rectangular is x is still r cos theta, y is still r sin theta, z will still remain z. You know, z does not change, it's still height, right? Okay, we can also say that x squared plus y squared plus z squared is equal to, no, not the one. We say x squared plus y squared is equal to r squared, and theta still remains the tan inverse of y over x. Tan inverse of y over x. Okay. Okay, so with this, we can look at some shapes in the cylindrical coordinate system. All the shapes that we look at in rectangular, we would see how they are represented in cylindrical coordinate system. Okay. Now, if r is equal to a, let r be equal to a in cylindrical, then what is this? If r is a, what is r? R is the radius, so r only works in the xy plane, right? So it means I come to the xy plane and measure radius a, and because I have not defined theta, it will go around like that. So it's a circle, like the polar. Okay. Like it's a circle. Because I'm not defining theta, it will go around. Right? Now I've also defined z, so I'm going to give the circle an infinite height. And given the circle infinite height, I get a cylinder of base radius a. Nice. We take a look also at theta is equal to pi on 7. Let me say pi on 4. If theta is pi on 4, what is theta? The angle our projected point onto the xy plane makes with the x-axis. So if this is theta, let me draw theta here. Right? Theta. Remember, I have not defined r. And what is r? The distance our projected point. The distance from our projected point to the distance between our projected point and our origin. But because I've not also defined r, it means my distance can go to infinity. If I give this distance a height, I'm also defining z. Then I get a plane. I get a plane. So it's going to be remember, we say here is our x. So if I have a point here, if I have a point in space and project it onto this, right, and draw a line here to meet the origin, I'll have some angle here, right? Right. Now, so an r, theta is equal to pi on 4. Once I get my angle, pi on 4, okay, I'm going to give this line an infinite height, and r will also go to infinity. So look at a line coming like that. It's going to make some angle. It's going to be a plane, right? It's going to be a plane. That makes a plane. That makes pi of 4 with the x-axis. That is what I'm trying to sketch here, right? A plane. That makes pi of 4. That makes an angle pi of 4 with the x-axis. Okay, nice. Now, still, if we let z to be equal to, let's say, a constant c, then obviously it's going to be a plane like that. That will cut z at c, like what we saw in rectangular coordinates. Okay. Let's look at how we define a sphere. Remember, a sphere in rectangular coordinate is x squared plus y squared plus z squared is equal to c squared. This is a sphere centered at the origin, right? But we know that x squared plus y squared is equal to r squared. It's cylindrical. You get it? We don't need x and y. Z could be there. The equation must be in terms of only r, theta, and z. So x and y squared is r squared plus z squared is equal to c squared. So now this is the equation of a sphere in cylindrical coordinate. We can also talk of the equation of a cone. Remember, a cone is z squared plus is equal to s squared plus y squared. In place of z squared and r squared, we can put z squared and y squared, x squared and y squared, we can put r squared, right? So z squared is equal to r squared. So z is equal to r is the equation of a cone in cylindrical coordinates. And also, we say a parabola is z is equal to s squared plus y squared. So z is equal to r squared. In place of s squared and y squared, I can put r squared, right? Z is equal to r squared is the equation of a parabola. Parabola. And the equation of a paraboloid in cylindrical coordinates. Okay, now let me see this. Let me go slightly back to rectangular coordinates. Now, if z squared is equal to y squared is equal to s squared plus y squared, we said this is a cone, right? About the z-axis. Also note that y squared is equal to x squared plus z squared. It's also a cone. But this time around, it's going to be about y. So open your mind about some of these things. So clearly, I can say that y is equal to r is also a cone in cylindrical coordinate system. A cone is what is about. Oh, sorry. I'm so sorry. Okay, so sorry. Let me leave it there. I don't want to confuse you. I don't want to confuse you, right? But just know that this is a cone about the y-axis. Okay, you've had enough of cylindrical coordinates. Let's move to spherical